Hello, grade 10 learners. Welcome to Get Smart with Stanford, where we make mathematics clear, simple, and fun to learn. I'm excited to have you here today. So grab your pen, your notebook, and let's dive into another great lesson that will sharpen your problem-solving skills and boost your confidence in mathematics. Today, we'll be working through a few important questions from factorization, simplification, equations, inequalities, and number patterns. All key topics you'll need to master your exams. So, let's get started. In question 1.1, we are instructed to factorize the following expressions fully. 1.1.1. They want us to factorize 4x minus 4 to the power 3. We have a common factor x, which we can extract and multiply what is remaining. That is 4 minus x squared, which should be simple to factorize because it is a difference of two squares. Our answer is x into 2 minus x into 2 plus x. To test if your factors are correct, you can multiply them and they must give you the original equation. If they do not give you the original equation, then something must have been done wrong and we would need to correct that. 1.1.2, we continue to factorize fully the expression x squared plus 15x minus 54. It is very easy to factorize these equations when you first find and list the multiples of the last term, which is the constant. In this case, it is 54. On the screen are the multiples of 54, and those that suit the equation are 3 times 18. This is simply because when 3 is subtracted from 18, the difference is 15, which is our middle term. And when multiplied by 18, the product is 54. So our factors are x minus 3 and x plus 18. And the next question, for y minus xy plus x minus 1, if we take out the common factor y from the first two terms, we will have y into 1 minus x plus x minus 1. But we want to change x minus 1 into a term that will be the same as the one we have in brackets. This must be done without changing the essence of this equation. We will then take a common factor of minus 1 from x minus 1. This will leave us with minus x plus 1, which can be rearranged to 1 minus x. To prove that the essence of this equation has not been tampered with, we simply multiply by the common factor minus 1. And you must get the original value from which the common factor has been extracted. Again, we have a common factor of 1 minus x, which we extract to have the final answer of 1 minus x into y minus 1. That is our final answer. In 1.2, we are instructed to simplify the following expressions fully, where 1.2.1 requires us to simplify x plus 2 into x to the power 2 minus x plus 3. On this one, we just take the first term from the first bracket and multiply all the terms in the second bracket. After that, we will also take the second term in the first bracket to multiply all the terms in the second bracket. After that, we just group the like terms to subtract and add where applicable. to reach our final answer of x to the power 3 plus x to the power 2 plus x plus 6. 1.2.2, we have 5 divided by 3 plus x minus 3 divided by 2 minus x. The first step here is to find the lowest common multiple, LCM, on the denominators, which is x plus 3 in brackets multiplied by 2 minus x in brackets. Let us now combine and simplify the numerator. There's nothing to cancel here, so our numerator is minus 8x plus 1. Then our final answer will be minus 8x plus 1 divided by x plus 3 in brackets multiplied by 2 minus x in another bracket. 1.2.3. Here we need to break down the bases in the numerator to make them the same as those in the denominator before we can apply the rule of exponents. We know that 25 equals 5 to the power 2. The exponent 2 will multiply the minus x exponent that is already there. 15 equals 3 times 5. And the exponent can be distributed into both 3 and 5. On the numerator, we now have a base of 5 multiplying each other. We will then write one base, which is 5, and add the exponents. From there, we again apply the quotient rule from the laws of exponents. You may refer to the video that I posted earlier titled Grade 10 Mastering the Laws of Exponents. Our final answer here is 15. In 1.3, we are required to determine the value of 3p plus q all squared. And that's if 9p squared plus q squared equals 12 and pq equals minus 3. Here we first expand 3p plus q all squared and apply the BODMAS rule, that is removing the brackets first by multiplying out. We will then rearrange to have 9p squared plus q squared, which I highlighted in pink because we were initially told that it's equal to 12. And 6pq is added onto it. I highlighted pq in blue because we were initially told that it is equal to minus 3. We substitute to get the answer of minus 6. Let us look into question 2, where we are required to solve for x in 2.1. 2.1.1 px plus qx equals a. Here we have a common factor x. That is why I highlighted it in gold so that you can see it. We then divide both sides by p plus q and find the value of x to be a divided by p plus q. That's it. 2.1.2. For 2x squared minus 5x plus 2 equals 0. We factorize to get x equals half or x equals 2. This one is very simple as that. If you do not understand, feel free to contact me. I will explain to you. But I've explained previously how we do the factorizations. 2.1.3. Half is raised to the exponent 3x plus 1. And all that is equal to 32. Again, we'll have to convert half into an exponential form. and do the same with 32. We know that 32 equals 2 to the power 5. Now that we have the same exponents on both sides, we can easily work on the exponents to get the value of x as minus 2. In 2.2, we are given the inequality minus 11 is less or equal to 3m minus 8, and all that is less than 4. So 2.2.1 requires us to solve for m. Let us transpose minus 8 to both sides of the inequality. Then divide by the coefficient of m, which is 3. We reach a conclusion that the inequality is minus 1 is less or equal to m, and all that is less than 4. The integers that satisfy this inequality are minus 1, 0, 1, 2, and 3. 4 is not included in this because the whole inequality is less than 4. It is never equal to 4, so 4 is not included. 2.2.2. We have mentioned the integers that satisfy this inequality in the previous question, and there are 5 of them, so the answer is 5. And those 5 integers are minus 1, 0, 1, 2, and 3. But here they did not want us to mention that. They just wanted us to tell them how many integers satisfy this inequality. So that's it. In question 2.3, we are required to solve for x and y simultaneously. And to solve simultaneous equations had forever been so simple. Let me show you how this is. So first, we will make 5x plus 4y equals 21, the first equation, and 2x equals 2 minus y, the second. From equation 2, let us make y the subject of the formula and call it equation 3. You can formulate equation 3 from equation 1 if that looks simple for you. You are not restricted from doing that. Now let us substitute equation 3 into 1. If you formulated equation 3 from equation 2, then you will substitute into equation 2. The value of x equals minus 3. Let's substitute that into equation 2. Then the value of y is 9. So simple. You would need to try a similar equation and contact me if you happen to get stuck. I will assist you. Let's quickly go into question 3, which is also so simple. We are looking into sequence and series, or the number patterns. Here we are given an infinite linear pattern. 20, 17, 14, they go like that all the way to minus 103. By looking at this equation, look at the first 3 terms there. We can easily see that there is a difference of 3 from the first to the second and from the second to the third. A is the first term, which is 20, and D is the difference, which is 3. The difference is 3. So, question number 3.1, the examiner wants us to find the 4th term, which is T4. Let's use the formula Tn equals A plus open bracket n minus 1 close bracket D, where A is the first term, that is 20, and n is 4, since we want the 4th term, and D is minus 3, since the difference is 3. Term number 4 equals to 11. In 3.2, we are just required to determine the precise formula for this particular pattern. We use the formula that we used in the previous question and substitute the values that we were initially provided with. So, there it is. Tn equals 23 minus 3. In 3.3, they want to know how many terms are in this sequence. That is the value of n. We know the last term, which is minus 103. We will substitute to the formula that we found on question 3.2. The value of n here equals 42. In 3.4, as we can see that the first term here is 20 and the rest decreasing up to 103. We want the value that is less than 0. Therefore, our Tn is less than 0. We know that Tn equals 23 minus 3n. We find n to be greater than 7.67 and we round that to the nearest whole number, which is 8. Substitute 8 to the equation Tn equals 23 minus 3n and substitute n with 8. The first term to have a negative value is minus 1. Going into question number 4. I just want you to study this pattern of dots before we can answer the questions and look at the trend here. We can see what the trend is. I'm very sure we're going to talk about that in this question. It's very important to notice what is happening in the pattern so that you are able to answer the questions. So now let us go and answer question 4.1.1. To get the fourth term, we will raise the pattern number to exponent 2, as that has been the trend from pattern number 1. So 4 raised to the exponent 2 equals 16. 4.1.2, here we will continue to raise 13 to exponent 2. Therefore, 13 square equals 169. So the 13th term equals 169. We go to 4.1.3. For the formula for the number of dots in the nth pattern, we simply say Tn equals n squared, since each term is raised to the exponent 2. Lastly, on 4.2, we have 1 plus 3 plus 5 plus all the way to 43. The first term here, if we look at it carefully, we'll see that it's 2 times 1. And 1 is subtracted from that answer. The second term is 2 times 2. 1 is subtracted from that answer because 2 times 2 equals 4 and minus 1, we get the second term, which is 3. And the third term is 2 times 3, which gives us 6, and 1 is subtracted from there to give us term number 3, which is 5. The equation here is Tn equals 2n minus 1, because each term is multiplied by 2 and 1 is subtracted from that. And this equation suits this pattern. Now, substitute Tn with the last term of the sum. The number of terms here is 22. And to find the number of dots in the 22nd pattern, we simply raise it to the exponent 2 to get 484. Raising it to the exponent 2 is because all the terms have been raised to the exponent 2, and that has been proved in the previous questions. That's it. Well done, grade 10 learners. You've done an amazing job working through today's lesson. From factorization and simplification to inequalities, simultaneous equations, and number patterns. Remember, mathematics is a language. The more you practice, the more fluent you become. If you enjoyed this lesson, Don't forget to subscribe to the channel for more lessons. Like and share this video with your classmates. Comment below if you have any questions or topic you'd like me to cover next. And if you'd like personal help or tutoring, feel free to contact us. The number and email address are on your screen right now. Thank you for learning with me here on Get Smart with Stanford. Here we don't just learn, we understand, we grow, and we get smart together. Ta-da!